All right, so this is week 3, day 3. We are going to be covering recursion today. For the first part of this, we're going to do a quick run through of the README just to kind of get familiar with it again. It sounds like a good a good majority of you should have already been exposed to it, but we'll go ahead and do another review, and then we're going to start breaking it down because this is one of those topics that can get a little complex and hard to wrap your head around. So it might take a while to understand what's kind of going here. But all right, so actually, no, we're not going to do the README. I'm going to use a different thing you've already seen because this README is going through a problem and showing it to you through a loop and then how to do it recursively. So we're going to do the same thing, but with something you have actually worked with fairly recently. And let's see. So that is going to be reduce. Do y'all remember reduce from, what was it, last week now? Or the week before? I'm getting mixed up in weeks. Okay, so with reduce, we did our from func tools, import, reduce. I'm going to just put up a simple reduce problem. This is going to be a some list, I guess. And that will take a list of numbers. Okay. With reduce, we feed it a function. I'm going to lambda this function, which y'all learned about last week. So this should be familiar. You have your two parameters, which are your accumulator and your current. What you want to do with your accumulated and current, I'm going to add them together because we want to sum this list. And then you pass it the iterable you want to use reduce on, so the list. And we're going to start at, for good measure, we'll start at 0. Okay, so with this function, if I had some list and I passed it like 1, 2, 3, 4, 5, then we expect this to return one number at the end, which we'll run it just to make sure. Did I not save it? I'm an example. I'm in the wrong spot. Okay. Jeez. There we go. And I didn't put a print. That's why it doesn't show. I do this every time. Okay. So here's a function we're familiar with. We looked in the debugger how this worked. It took a function and it compared items 2 at a time as it worked through this list. And in the end, it accumulates that value and shoots out our total. So we kind of get how that works with reduce. Now, recursion is actually very similar to reduce in the fact that it also accumulates and is going to return something at the end. There are a few key differences. So with reduce, this this calls a function that handles combining these elements as it steps through the iterable. But it does all of its iteration behind the scenes. So we know that when this is iterating, it's always going to take the accumulated and the next value, the current value, and it just steps through one at a time, your iterable object. So we don't have any way to control how it's going through this problem. It's just going from one end to the other. We can't control it. It does that all behind the background. So recursion lets us define how we want to break this problem down. So we can tell it to break it into smaller pieces in a different way. Doesn't necessarily have to go one at a time through each individual element. You can do different things with that iteration. And reduce also returns one value. We see here, returns a 15. Recursion can and often does return one value, but it will also return different things. It can return multiple values, it can return structures, it can return side effects. So that's kind of the main differences in these two. Reduce is a little bit like it, but it does a whole bunch of lockdown stuff to it. And recursion, we're going to go ahead and define a lot more of the elements of this. So we're going to try using recursion to do this kind of summing all numbers in a list. Now, each recursive, somebody said it before, for each recursive solution, let's do, just gonna do the same thing again. Trying to get more explicit with my like parameter names so y'all don't copy me just putting list. Okay, so for a recursive function, it requires two things. What's the first thing it requires? Or one of the two things?
A base case?
Yes. So first one is going to be a base case. What is a base case? What does that mean?
That basically like the condition that stops it, right?
Yes, this will be, it's a good way to think of condition that stops. It's also, you can also think of it as the most simple form. Some people say it's the simplest form of this function or the most simple problem it can solve. That can kind of be confusing. So we'll just put it up there. The most simple problem, I guess. Maybe good explanation, but it's basically where you want it to stop. Otherwise, if we call a recursive function, so a recursive function is going to call itself over and over and over. And if we don't give it somewhere to stop, it's just going to keep going. And the computer will have a little Stack Overflow problem. And then what is the next thing it requires? I'm going to call on somebody because I don't want the usuals to answer. Let's see. Let's do Allison.
My best guess would be what you like the steps that you want it to do or the function.
Yep, that's one part of it. And also, so it's called the recursive case, which is what we're going to want to do to this. Like, we want to do this problem. And it's also the way we break down this problem each time. Because if we don't make it smaller each time we're working on it, it'll just produce the same thing over and over and over again. So in this part, we need a way to step down this problem into smaller pieces, if that makes sense. Okay. We'll have some examples, so it'll get a little bit easier here to start making sense of it. It's also, let's see, how we break this down to reach our base case. Okay, so let's think of if we're given this list of numbers here. I can type today. If we want to, well, we're not even looking at this right now. If we want to add all numbers together in a list, what is the simplest input we can receive for that?
Would it be add?
Well, if what's another way to put this?
The-
So we're trying to break this down to something smaller instead of giving it a whole big long list.
Oh.
What's the
in math.
simplest version of this we can kind of work with? Or when would we want this to stop?
Once
you
the index is 0.
Well, an index of 0 would be this first one.
The length of the index.
Okay. So the length of the list, when the length of the list is 0, that's a good base case for sure. Because if we were to do summing a list and we just pass it an empty list, the sum of this list would be 0, correct? That's probably the easiest we can get with this problem. If I just throw it an empty list, I want it to give me nothing back. I want it to be 0. So we can work down, so this will be our base case, and we've determined that the way to state this is if the length of our list is 0. Okay, so we did, and this is our base case, if the length of this, can't remember what I called it already, list of numbers, is equal to 0, then we want to return 0 because that is empty and it doesn't have a value. There's nothing to add with it if there's empty. Okay, so that's our base case. That's when it's going to stop. Now for a recursive case, how do we want to break this down? How do we want to get from here to here? What do we think we can do each time to go from here to here? Let's not think about what we're doing with the problem yet. Just how can we break this down each time?
You can do a return of the list, and then you put the return list of none, and then on the outside put the brackets, and I think it's, what is it, dot, or is it just dot up to the length of the list minus 2.
Let's see where you're going. An easier way to do it is let's just take everything from the first number on. Like we'll leave off the first number, but we'll take everything at index 1 and after.
Okay, yeah.
So probably could have done the other way, but this way seems a little bit, it's kind of like we're stepping through it then. So we look at this first one, and then the next time we're going to take this list, and then we'll look at the first one there, and then the next time we'll take this. So for now, what we've got going on is each time, well, so that will return just this list of numbers from 2. So if we run this, we feed it 1, 2, 3, 4, 5. It's greater than 0, so it's not going to return a 0, but it will return 2, 3, 4, 5, and then it stops. We don't want it to stop, we want it to keep going. So how can we get it to keep going instead of stopping here?
You return some list and you pass in your new portion of the list into as an argument.
Correct. Okay, so this we'll take that 2, 3, 4, 5 and call this again and work through it again. So now we've got it working through. We've got it reducing down. So each time it goes, it should get shorter and shorter and give us a smaller chunk of the problem. But we're not doing anything with it. Right now we're just reducing it. So what can we do to add these together each time? So right now, if we run it the first time, we're going to have 1, 2, 3, 4, 5. And then, so, okay. This might be helpful for y'all, might not. This is what I used to do in Recursion just to kind of see what was going on. But I'd write the first run, you have like 1, 2, 3, 4, 5. Okay. Then the next call, you have 2, 3, 4, 5. And then the next call, you have, and you just keep kind of working through to see how it's breaking down. But we still got to do something with these numbers we're taking off each run. And since we want to add them together, I think we can probably add it somehow.
On line 16 at the end.
At the end?
Just add, and then that'll be a list of num 0 index.
Right. List of num index 0. So now we're capturing that 1. And this is not a good way to look at this. So the first time we're capturing that, we're doing some list. This is what I meant to do the first time. I'm so sorry. Of 1, 2, 3, 4, 5. Okay. The next run, we are doing some list of 2, 3, 4, 5 plus 1, because that is right here. So then we got to run this again because we don't know what this number is. So the next iteration it runs through, it's going to call some list on 3, 4. Oops. Push 3, 3, 4, 5. And at this point, we will have plus 1, plus 2, basically, because we took this 2 off now and added it on the end. And it keeps going until we get to the very, very, very end, where it'll eventually be all the numbers just adding together as we've reached the end of this. I guess I'll step through it to the very end here. 4, 5, plus 1, plus 2, plus 3. And then just keeps going until we reach our base case with the length of 0. Plus 2.
Maybe I'm not seeing it, but won't this just return 0? So if you put print and print it out, won't it just go through and add until the list gets to 0, and then it's just going to return 0, as in return 0 integer?
So that's a good question. What this is doing is this is the recursive stack. So when you're running this function, it's going to stack all of these kind of function calls as placeholders until the very end. So at the very end, we'll do this here. So now we have, this is the very end. We're calling some list, oh gosh, on empty plus 1 plus 2 plus 3 plus 4 plus 5. Okay, so now once it's hit that end case and it returns 0, it'll plug in 0 here because the value of some list of an empty is 0. So it'll plug 0 in there. And then it'll basically come back up through. We've just kind of wrote it all out on the side. This is kind of hard to see, but so we'll kind of work up the stack like this. Forget these numbers for a bit. It's holding those for later, but it's working up the stack. So now it's calling some list of 5, which is 5. Oh, that's not a good example. Sorry. Basically, once it hits the 0, it's going to come back up through and do everything else.
I mean, it started to make sense to me, I think, when you left the 0 plus 1 plus 2 plus 3, because it's no longer calling a function. It's
Yes,
basically putting all that stored together and then
correct.
outputting that.
So another
Oh,
way to look at this is going to seem kind of crazy, but this might help visualize it more, is you're basically calling sum list, sum list, sum list, like very nested calls of this function multiple times. And if you feed it a value here, like 3, it needs to, this is not, it can't call this function first because there's no values in here. These don't hold values until these functions return something. So in order for this to complete, you need to solve the smallest case first, and then it will resolve through the outside functions.
or the smallest case being the base case.
Correct. So the
Okay,
base
so
case,
everything is held in place, so to speak, or like you said, stacked until you get to that base case, which for our example here is 0. It's not calling itself anymore. So then it starts doing everything up the stack and returns the stack answer, so to speak.
yes,
I
exactly.
I don't see where it's adding 5.
So right here, after this one goes, the sum list of 5 is going to be that current number. So it'll call it again with an empty list plus the 5.
Oh, I see. Yeah, just
Yeah.
one more. Okay.
But yeah, this is kind of, I mean, this kind of helps explain that stack. A lot of people will also say it's like putting plates on top of each other, and then you work from the top and pull that off and work your way back down. I don't like that either. I like,
Using the debugging helped to kind of visualize it too.
yes, debugger is definitely helpful for recursive cases. But this, I mean, hopefully this makes sense too, where you can't call this function because it doesn't know what these numbers are until the last one, the base case, works. This is just kind of a way to show you how it's running through this each time and storing those values, because these values are just held here because it's waiting. It's waiting for 3, 4, and 5 to get resolved first. It doesn't know how to handle this. So then it keeps working through until you hit that last one, and then it just, everything adds together at the end. So, any questions on this example at this point?
So minimum things you need is a base case, and then your else statement there, which is the recursive case, which is just it calling itself, and then what it needs to do to get to that base case.
Yes, correct. We're going to go through a couple other examples here, or at least one more. So I'll tell you, with list problems, a lot of time your base case is just going to be an empty list because it's like an iterable if you work it to the end. So a lot of problems you can just use an empty list as a base case if you're working with lists. If you're working with like numbers, maybe the base case is when you either get to 0 or get to a certain number, and then you figure out how you want to manipulate that to reach those cases. But more often than not, a list, you're just going to be breaking it down into smaller lists, whether or not you do it one at a time or maybe take larger chunks to break down. That's up to you. Is any part of this super confusing still, or need a different way of explaining it? We can also, I guess I can run. Let me run. We can run it in the debugger and watch it.
Lay down. Lay down.
Oh, Kim, you're on mic still.
I'm sorry.
I would love to lay down after class. Let's see. Okay, so Does this look like it'll work? Do I have everything situated? No, because I don't have a breakpoint. Let's put in a breakpoint. Okay. So we will step in. Here we have our list of numbers, and down here is where you'll have your call stack. That will eventually, it'll grow, but then it'll stop and it will resolve. So here we've determined it's longer than 0. So we are going to call this function again and add it to the number at the beginning. So now here, it's just saved that. It's just saved it down here in our stack, that number. But it's running again with the new list that we've created because we've called it once again. And it'll do the same thing where it's going to save that placeholder right here in the stack. And then it calls it again with a lower. And this is where it's holding those values until we get to the very end here. So we'll watch it shrink down and it's adding to the stack. Now we get to the 5 is going to be the last value it needs before it hits our base case. So now it's going to hit our length of 0 and it's going to give a 0 value. So now it's going to work back. This is the return of the first thing in the stack that we saved, that 0 value. And we're going backwards. Remember, we're going from the base case back through so it can resolve the function calls higher up. So the first one that we have in the stack returned to 0. Now we're going to go to the next one, which was these two. Or this, I'm confused about this list of numbers. We can see that that sum list resolved and it gave us the 5. Let me see what's going next here with this. Okay. It's showing how the list, it's going backwards through and including all the list of numbers from backwards to the front as it's resolving this call stack. So that's our list that we passed in. But it's resolving each of these each time and returning the value and adding it together with the one that it had just resolved beforehand. So we had the, let's go back. That's confusing.
Doesn't it need a print?
Well, if you want to see it in the console, but I'm just looking at it here.
Okay.
Okay, so I want to get to the point where we have the stack again completely up. Okay. So now we're at our length of 0 and we're going to follow this again. Okay. So the first number we had was 5. And then we're calling some list of 5. No. Somebody want to take a stab at explaining this better? I can hear it in my head, but it's not coming across well. Let's... Like, this is throwing me off. Who is it that said? Was it that said the debugger was good to visualize this?
I did, but I wasn't talking about this example. It was just
Okay.
whenever I was doing research for it. But I mean,
Oh.
I don't, is this because the length is, no, because that's for 3. But the previous, when we were looking at it before, made sense, at least to me, that like once it hit the base case, it started back at 5 and then was adding 4 and then adding 3 and then adding 2 and 1. But I don't know what that 0
Yes.
equals 3 and 1 equals 4 means.
Is that just 0, 1, 2 are the indexes?
Yeah, it seems like it.
Like at the time that they're adding it. Yeah.
Yeah.
Yeah. Yeah, honestly, I've never used the debugger to look at recursion. I just kind of write it down and visualize it this way. But it looks like it's just kind of recreating that list where it was in that function at that time that it was called. Possibly. But it is a good way to show you that it goes all the way to the bottom and then it works its way back up, adding everything together that it had before. Okay. I need to, let's see, I'm going to pause for a minute. Let's see. Okay, so let's start again. Okay, any questions on this after we had that confusing little side? But that was, we had in the chat there, was it John? You pointed out that that was the index backwards, working backwards through the list. So that makes sense. Okay. So we are going to go on to another problem now. Let's see. And for this one, we want to, our input's going to be a list again. We like our lists. And our output, we want to reverse this list. Okay, so we will define our reverse list. And we'll take in a list of nums. All right, let's think about our base case. Kind of touched on it before. We're working through a list. It's a good idea for the simplest form of this problem, or the where we want it to stop. We're talking, but we've already discussed it. If the length of this list is, let me move the chat. If the length of this list of numbers is 0. So if we pass in an empty list, now with this, if we want to keep this in a list, do we want to return 0 or do we want to return something else? Any thoughts from anybody?
Are you saying return a list instead of the sum of the list? Is that what you're saying?
Yep, we're going to return a list just backwards. So we're not returning a value this time, or a single value. We're going to return a whole list. So let's think about this. If I pass in a list that's empty, what do I want that return to be?
An empty list.
Yep, I want it to be an empty list. That's the simplest answer to this problem, where we want it to stop. We want to stop when there's nothing in the list, and if there's nothing in the list, there's nothing to reverse. We just want an empty list right back. That makes sense? Okay. So now we got to figure out how we're going to break this down. So our recursive case. It's going to annoy me if my spaces aren't all the same. Let's see. So we got our else. Now, how do we want to work through this? If we're working through a list, I think we like the idea of just kind of, knocking one number off and taking the rest of it. It's a good way to reduce a list. Right? We like that approach. Yep, so that's our, okay, we're gonna, guess we don't have to return that yet. Well, yeah. And we're gonna call that list again in our recursive function, return first list, and we're gonna do that on list of numbers, but from index 1 and on. So now each time we call this, our list should get shorter and shorter. Okay, so now the tricky part is figuring out what we want to do to achieve this. So let's take a different approach and work backwards. So if we have our reverse list and we pass in an empty list, we know that this is all going to be commented out. That will return a empty list. Okay. So now, because recursion, works down, it builds up that call stack and then works backwards. So if it's working backwards, the next call of this with our example should be just a list of 5. So what can we do? What do we want our return to look like if we have the 5?
Just a 5?
Yep, we'll just have a 5. Okay. So how can we get this output? Because we don't have this anywhere. We're not able to return, our base case does not return the number that it's on. And right now we're just kind of working through our list. So how can we return this 5?
Can you print list of number?
Can we do what?
Can you like print underneath return? Like that's what it would print or return?
Well, we want to return the value. We can print will just show us what we're working with. But right now I'm trying to figure out how can I want this output. What function can I write if I give just a single list value of 5? What function?
Can you just return num of list index -1?
Or just index 0, because it's the only number in the list, correct? If we're looking at this right now, I've just given it a list of one number. And if I want it to give me that list back with that number, we can call that, we can do, because this is our parameter list of numbers. Our list of numbers is just that. We can just do, well, we can call list of numbers, but we can also just list of numbers 0. But if we do list of numbers 0, does that give us a list? Or is that only going to give me a value of 5?
Looks like it would just be a 5 right now.
So
Right.
then how can we make this? I want it to be a list. I want it to be a list with that value of 5 in there.
Can you just do list and then put that in parentheses?
In list, or we can just stick it in a list.
Oh, love it. Okay.
Okay, so this is how we can get that value if we had one number in there. So if we're working backwards, this base case returns this. What do we want to do with these two outputs to kind of build our list up backwards?
Want to add the first value in the list to the end of the list
Yep, so we
until
want,
it flips.
if we're working through it, yep, we want to take that last value will come into the front. So if we're working through this like this, we're going to take that first value and stick it on the very end. If we are working our way this way, we just want to add this plus this. Did you know you can do just this plus like an empty list plus 5, and it'll combine them. That will equal 5. So you can also do, let me see, I don't know how best to, you can also take like a list of 3 plus a list of 5, and that gives you 3 and 5. So we can add that output we got here in the second iteration to this empty list, but we're not doing that in our problem yet. So if we're thinking through this, starting at the beginning, it's first going to take that 1. Actually, no, that doesn't matter. So we just want to add, we're going to add this on to whatever comes before it. So we're going to add that list, like we did here, this list of numbers. We want to add that to whatever comes before it when it's working its way back through the stack. So this might seem a little confusing. Let me go ahead and I will work through this together of what this does. So the first call we have at our base case, we return an empty list. Next. So then if we do reverse list of 5, that's going to give us a 5. So now we do the 5 added on to the first one here. This is going to show, hopefully this doesn't get confusing. So I'm going to do this function call on each item backwards, like it does after it gets to the end of the recursion call, and show the accumulated output here. So we had this one from the first function call, and we told it each time we want it to add the value. So then this one is going to be 5 because it's empty. So then we call here reverse list of 4, which will give us, we've identified we want to pull out that list of number here, 4. And we want to add that into the other list of numbers. So now we had 5, and then we're going to add the 4 onto it. The next run, it's going to do, let's see if we can see this better in the debugger here. I am going to see if this shows better in the debugger, but we'll see. Okay. So right now it's hitting this reverse list. It's going to take 2, 3, 4, and 5 and add in the 1. It's going to hold that 1 though, kind of like we did up here. It's going to take that list and hold that 1 until the end. So now we have 2, 3, 4, 5. Let's see. And at this call, it's going to come back down here and it's going to split it up again and just take 3, 4, 5 and hold the 2. Because it needs to work through all the way to the end. So now we have 3, 4, 5. And each time it's going to hold these numbers, the first one is going to hold this 3. Until the very end, when we reach the end of the stack in our empty list. And now it's going to come back through So we're returning the reverse list equals empty first, empty list first. And then we add in that number we stored from the last call. We stored a 5 here. So we're adding that in our empty list. And then we're going to go to the next number we stored from the 4. We just, took that off, and we're storing that list of number on the side, and we're going to add it into our list that now has 5, 4. Same with the 3. It's just going to keep putting that back on until the end. Is that extra confusing, or are we sort of following? So each time it runs this, it's going to do holding that value of reverse list, calling that list of numbers from the next one over here. So I'm trying to give multiple ways to visualize this, hoping something clicks. And it's going to do that, plus on this first run, that list of numbers 0 value in a list is 1. Okay, so it's holding this for later until it resolves this first. So the next iteration, we reverse list. This time we chunked it down again. No, I'm sorry. Just think that the first time it ran, it gave us that, because we know that was our base case. Okay, so now again, we're going to chunk it down one more. So now we have the 3, 4, 5. And it's holding the 1 and the 2 now from the previous. The 1 was from the previous stack, and the 2 is this current stack call. And I'll keep doing that. If I can type 4, 5 in a list, of course. Oh my word. Had to pick a problem with lists. Okay. And in this one, again, that list of numbers it's currently on, that first one in the list is going to be, did I skip one? No, this is when it's returning. Okay. Is anybody confused by this right now? So this input is going to be the full list the first time. Sorry. This first input, this is when you feed in the full list, and it gets down here, and then it's calling it again with the cutoff list and that 1. And then this list here is going to be where the parameter we're passing in is 2, 3, 4, 5, and it's going to return the list shortened plus the 1 and the 2. And then we pass in our 3, 4, 5 back again up here, which returns the list chunked down again to just 4 and 5 plus the 1 plus the 2. And now this time we pulled off the 3 to hold that value until later. Of course, we get to the last one here, 5. That's gracious. And our previous values we've stored in the higher, in the previous stacks that we were just holding in our call stack. And at this point, we're going to save that 4. Oh, it's not the last one. This is the last one. When we hit the empty list, that's when we want it to stop. So when we hit the empty list, and we have all of our stored values here, plus 5. Finally, we've reached the end here. We can, this last one, is our base case, it'll give us just an empty list. And it will add all the rest of these in there, but backwards, okay? Don't get confused by this because it's going to go backwards through here. It's storing these numbers, but it's not a simple, I should have showed up here. It actually would have added these from the 4 or the 5 backwards because it's going backwards through this stack. Does that make sense? Yes, no?
I finally had a light bulb moment when I realized in the base case, when I was returning that empty, well, all of it, we're so used to returning to the console. It's not returning the console, it's returning to line 43, right? It's going back to that function, not to the console or whatever.
So, trying to follow, the base case returns this value, but because we've saved all of these function calls waiting, we're basically waiting for this value to be able to plug it in going backwards through this problem. Kind of like when I wrote it right here. We were waiting for that very last one to run to take that value and plug it in next. So when we hit this base case, we finally get that value and then we can go back and it'll then come here and take, well, it won't come to that. It'll take the last value we had plus what was provided by running that.
Yeah. I was thinking just like Sean was, it took me a lot longer than it took him to get it. I was thinking, why wouldn't it return 0? But it's returning it back into that function, not the way we normally would think of it. Okay, that's okay.
Yes, returning back into the function. We're kind of just putting placeholders up and working our way through until we can finally get that last thing we need to complete our whole function. Any other questions on this? We are going to have the opportunity to practice, and there's lots of, if I didn't explain it well, there's plenty of resources that you can look at that might do different ways of explaining it for you.
I love how you typed that out. Are you gonna put that in Slack for us? Like,
yeah, I can do that.
Thank you.
I don't think I've ever seen anybody else write it like this, so
No, that's really good.
I might get some frowns for that, but I don't know. It just kind of helps watch that this is the placeholder values. These already have values, but they're still waiting on the other ones to finish. So it just works through the stack, I guess, without having to think backwards through it. This kind of keeps it all in one flow for you. But yeah, that's recursion. Base case and a recursive case, you try to take your larger problem and break it down into smaller problems to solve. And then it accumulates and produces an output at the end. So I can definitely share that. That's going to be it for lecture tonight. Let me stop sharing or stop recording.